Rule number 12. JD has a summer job mowing lawns. The following amounts represent his earnings for mowing 5 lawns. $22, $25, $20, $18, and $25. We should first put those dollar amounts in order from least to greatest. So 18, then 20, 22, and we have 2 25s. The first question is, I have 1, 2, 3, 4, 5 here and 5 there, so I didn't miss any. Which measure is not represented by $22? The mean, median, or mode? So the easiest one to check is the mode, and there are 2 25s, and none of these other pieces of data occur twice, so the mode is 25. So if we're trying to find the one that is not represented by 22, oh wait, that's the answer then, right? The mode is 25, and that's not 22, so the mode is the answer here. We should check what the mean and the median are just to make sure that we didn't overlook something. The median is the middle number, and the number in the middle, once we've ordered them from least to greatest, is 22. And the mean, we assume it's 22 because we feel we've already found the answer, but just to be sure, if you add these up, that's 50. 22 and 18, if I associate to my advantage, would be 40. 50 and 40 is 90, and 90 and 20 is 110. And then we have our total, we take our total, 110, and divide it by 5 numbers. 100 divided by 5 is 20, and 10 divided by 5 is 2, so the mean is 22, as is the median. So the mode is the answer here. That's the one not represented by 22 because it's 25. If JD mowed 2 more lawns and earned $14 and $23, which measure would change, the mean, median, or mode, and what would it change to? So let's redo our list. We've got a new lowest value, 14, then 18, 20, 22. We've got a 23 now, and we have our 2 25s. The only numbers that occur more than once are still 25, so the mode is still 25, so the mode did not change. The median, the middle number, 22, and it was 22 before, so the median did not change. So since the 3 choices they gave us are mean, median, and mode, the mean must have changed, but let's make sure. 50 here. I'm going to use that same association here. 18 and 22 is 40. So this is 50. These add up to 40. And 20, 23, and 20 and 23 are 43. And 14 is 47, 57. So 50 plus 57 plus 40, well, 90 and 57, 147. And 147 divided by, I have 1, 2, 3, 4, 5, 6, 7 now. That makes sense because I had 5 before and I added 2 more. That gives me a quotient of 21. So the mean was 22. The mean is 21 now.
Problem number 13. How many quarters worth 25 cents each must be added to 12 nickels worth 5 cents each so that the average value of a coin in the new enlarged collection is 10 cents? So let's make a table. Nickels, quarters, and then the mean. We know that when we have 12 nickels and 0 quarters, we know that the you know what I should have done? Let's put the total amount of money that represents here, and then let's calculate mean right here. Okay, 12 nickels worth 5 cents each, so that's 60 cents. Let's make this cents instead of dollars. 60 cents, and 60 divided by 12 is 5. That makes sense. If they're all 5, the mean should be 5. I don't know how many quarters we'll need, probably more than one. Let's try 2 quarters. 12 nickels and 2 quarters. I still have my 60 cents here, plus 50 more cents is $1.10. And I'm dividing by 14. I don't really need to calculate this mean. I could, but I don't really need to, because if I know I want the mean to be 10 cents, this dollar amount, this amount of cents, I should say, when divided by the sum of these two, it should be 10 times more than the sum of these two to give a mean of 10. In other words, if I have 14 coins here, I should have $1.40 here for the mean to be 10. So I don't really need to do that. I can just try another value. And I don't think it's going to be 3 quarters, because then I'm going to have 60 plus 75. I'm going to have that extra 5 cents hanging there. That's not a multiple of 10, so let's try 12 nickels and 4 quarters. So I have 60 cents plus $1 is $1.60, or 160 cents. And I have 16 coins in total, so 160 divided by 16 is 10. So the answer is 4 quarters. There are many other ways to think about this problem. I'm going to talk about 2 of them, because I like to try to teach you some extra things on the video when I can, without hopefully making it too long. Let's think about this. We have 12 nickels. Let me just show them. There are my 12 nickels. If I add a quarter, remember, I want the mean to be 10 cents. So I need to be able to take money away from the quarter to get it down to 10 cents. I'd be taking 15 cents away. If I take 15 cents away, that 15 cents can be given to 3 of these nickels to make them each 10 cents. So I have 4 groups of 3 nickels that need to be raised up to 10. It would take 3 more. It would take a total of 4 quarters to do that. I hope that makes sense. I'm taking, if I want them all to level out to 10 cents, I'm taking 15 cents away from each quarter, and it still has 10 cents. And that 15 cents can raise 3 nickels up to the 10 cent average. I would need to do that 4 times to cover all 12 nickels. There's also an algebraic approach that you'll learn in a couple of years, where we have 60 cents plus 25 cents multiplied by the number of quarters would be the total amount of money we have in cents, divided by the number of coins, which would be 12 nickels plus the number of quarters. And that would be the average, because this is our total amount of money divided by the total number of coins. That would equal 10, the average. And then you would apply property of equality, multiply both sides by 12 plus q. I'll show it here. That would cancel this out. That's the multiplicative inverse. And you get this, you're applying the property of equality by doing the same thing to both sides. You have 60 plus 25q equals, I'm going to distribute this 10 to both terms. 10 times 12 is 120 plus 10q. And then I don't want q on both sides, so I subtract 10q from both sides. And I get 60 plus 15q is equal to 120. And then I want to isolate q to determine what q is, so I subtract 60 from both sides. Again, property of equality. I get 15q is equal to 60. Well, 15 times what is 60? 15 multiplied by 4 is 60. Or you could divide both sides by 15. 60 15ths is 4, so q equals 4. That's the algebraic approach. That's what's fun about math. You're at the point now where you're most likely going to do an organized guess and check with a table. But the next level is understanding mean conceptually, and then the next level beyond that is creating algebraic expressions and equations and solving for variables. Okay, problem 14 again is another problem taken directly from SAT test prep materials. These are well within your range already. The frequency table shown here, a frequency table is very much like a line plot or a stem and leaf plot. It rather than have a long ordered list, like if I was going to make this list from least to greatest, I see one student had a score of 50, and I see 5 students had 60. Rather than have this long list of data from least to greatest, we just, all of the data that occurs multiple times is represented by its frequency. 5 students, there's a frequency of 5 students that scored 60. And so we can use this the same way we use an ordered list of data or stem and leaf plot or a line plot. So the frequency table shows the number of students and their scores on a math test. If the median of the test is 75, remember median means the middle number, which of the following could be the value of n? Well, 75 is not, n represents some number of students that scored 70. There are no students represented or shown on this table scoring 75, but it can still be the median as long as there are 2 numbers in the middle that average out to 75. And the only way that's going to happen with this data is if 70 and 80 are in the middle. And for that to happen, we'd have to have an even number of data points, and there have to be just as many above 75 as there are below 75. So 2 plus 4 plus 6 has to be equal to n plus 5 plus 1. Well, 5 plus 1 is 6. This is 6 plus 6. So n must be 6. We have to have 12. We have 12 numbers here. 6 and 4 and 2 is 12. These have to add up to 12. 5 and 1 is 6, so n must be 6. To give us 12 numbers that are 70 or less, and then 12 numbers that are 80 or more, so that 70 and 80 are the middle 2 numbers, giving us a median of 75. So the answer is answer choice C.
Problem number 15. Megan's number is the average of 1/3 and 1/2. Melita's number is the average of Megan's number and 1/2. What is Melita's number? This is a simple problem. It's just that the data that we're using are fractional. So we know to find the average or the mean, we add the numbers together and divide by how many we have. So if I construct a complex fraction to see this, it would be 1/3 plus 1/2, and I take that total and divide it by 2 because there are 2 numbers. So we can work like this. Just we need a common denominator. We need to create like terms. Thirds and halves are different size pieces, but if I make them both sixths, in other words, 1/3 is 2/6 and 1/2 is 3/6, then I'll be able to combine like terms. And 2/6 and 3/6 is 5/6. And this is what I mean by a complex fraction. When you have a fraction in your numerator or denominator, we call that a complex fraction. But remember that the fraction bar of the vinculum indicates division. So this is the same as the expression 5/6 divided by 2. And we know from the definition of division that dividing is the same as multiplying by the reciprocal. So dividing by 2 is the same as multiplying by the reciprocal of 2. If you think of 2 as a fraction, 2 over 1, and the reciprocal would be 1 over 2. Reciprocals are 2 numbers, I almost said 2 fractions, but they don't have to be. 2 numbers that when multiplied together give you a product of 1. So you flip the fraction to get a product of 1. So the reciprocal of 2 is 1/2, and 5/6 multiplied by 1/2 is 5/12. So that's Megan's number, 5/12. Melita's number is the average of Megan's number, which we now know is 5/12, and 1/2. Again, we'll add those together, take the total, and divide by 2. I can make halves into 12s, so I'll just keep 5/12. But I know 1/2 is 6/12. Divide that sum by 2. 5/12 and 6/12 is 11/12. And 11/12 divided by 2 is the same as 11 twelfths multiplied by the reciprocal of 2, which is 1/2. Dividing by 2 is halving something, right? So it's the same as multiplying it by 1/2. And then when I multiply, I get 11 over 24. That's Melita's number, and that's the answer to problem 15. Thank you for taking the time to watch the videos, the ones that you needed to watch to prepare yourself for your first unit test. I know you're going to do great. Thanks for all your hard work.